Well, greetings everybody. So here you'll see a problem that is on our assignment on my math lab, and I want to pay some special attention to it for a few reasons. One reason is that we use the critical value in this problem to make a decision about the hypothesis test. And then the second thing is that this final response down here is written in terms of not necessarily whether we accept or reject the null hypothesis, but accepting or rejecting the claim. So we'll talk a little bit about that too. Okay, but here's what we're given. Somebody makes the claim that the population mean is not equal to 5,000. Okay, that's just a claim. It by itself has nothing to do with hypothesis testing, but that's the claim that's given. We're given some other information that we would use to do a hypothesis test, and we can proceed like this. So we always start with saying what are the null and alternate hypotheses, and this claim is not the null hypothesis because it doesn't involve an equality. If that said claim population mean equals 5,000, it would be the null hypothesis, but that's not what it says. It says claim population mean not 5,000. Okay, so that makes it the alternate hypothesis. And then the null hypothesis is whatever true if the alternate is not true. So that would make it that the population mean is 5,000. Okay, so from that claim, we can make a statement about what the null hypothesis is and what the alternate is. So let's go from here and do some of the math, okay? Because I said the critical value is involved in this, so let's talk about that. So what are critical values and how can we use them to make an ultimate conclusion about this, okay? So let's talk about just how do you calculate the critical value. It depends on what the null hypothesis is, okay? So I have the three cases here of how you calculate the critical value. And it depends on what the null hypothesis looks like. So it might be that the null hypothesis says something like the population mean is greater than or equal to some number. Okay? If that's the case, the critical value is the value on the standard normal curve that has an area of alpha. So alpha is the significance of the test. In this case, it's 0.04. Has an area of alpha to its left. Okay, so is that the case we're in? Does our null hypothesis read population mean greater than or equal to some number? Not in this case. It doesn't look that way. Okay, some of the problems are like that. Maybe the null hypothesis in some other problem says population mean greater than or equal to 5,000, but not in this case. Okay, so my point is, like, case one is completely valid if that's what you have, but it's not the case here. And then there's case two. Okay, that's not what we have either. And then case three, what's that one look like? It's the case where the null hypothesis reads like this. Population mean is equal to some number. That's where we're at. Okay? All right. Now, how do you find the critical value? Well, it is plus or minus the value on the standard normal curve with area alpha divided by 2 to its right. Okay. So there we go. Let's do that. I'm going to bring up the standard normal curve through StatCrunch. This is the way that we do things. It's included with my math lab, so it's always what I use to do calculations with the normal distribution. There's the standard normal curve. And what did it say I needed to do? I need to find whatever the value is on that curve that has an area of alpha over 2 to its right. Now, in our case, alpha was given to be 0.04. Every hypothesis testing situation has that number. So alpha 0.04 divided by 2 is 0.02. That's what that number is. I need to find the value on the standard normal curve with an area of 0.02 to its right. All right, so here's how we can do that. So I'm going to put this as greater than, because then it's finding areas right. And then I want that area to the right to be 0.02. So what I'll do there is I'll put 0.02, okay, and do calculate. And see, it's a little more than 2. The spot that has area 0.02 to its right is 2.0537489. Okay? There's our critical number. It's going to be plus or minus that. Now, look at the answer on MyMathLab. Plus or minus 2.05. Okay, so look. It says round to 2 decimal places. All right, I got 2.053. So that's why the answer is plus or minus 2.05. Okay, so there's our critical value. All right, and you see it depends on 3 cases which case we're in. Just look at the null hypothesis, figure out which case you have, and you calculate the critical number. Okay, so that's part 1 of what I want to say is how do you calculate the critical value. Part 2, how do you use that? Say we've got the critical value. How do you use that to make a conclusion? Okay, all right. So to do that, to make a conclusion, and by make a conclusion, I mean, well, then do you reject the null hypothesis? Do you fail to, what do you do? Okay, so here's how we make that conclusion. You calculate the standardized test statistic, which is sample mean minus population mean, divided by population standard deviation, divided by, again, square root of sample size. Okay. So I will calculate that for this problem in a minute. Turns out it's 6.59. But with that number in mind, here's what you do. So see, I have 3 cases once again. So these are the same 3 cases as over here. Case 1, null hypothesis reads population mean greater than or equal to a number. Case 2, population mean less than or equal to a number. So these 3 cases about what you do with the standardized test statistic, STS, in order to reject or fail to reject the null hypothesis. Okay, it maps up with this. So which case are we in? Were we in case 1, 2, or 3? Well, we were in case 3, okay, because our null hypothesis reads population mean equal to a number. So here's what it says. Now, if you're in the other 2 cases, and this is how you decide to accept or reject. Okay, and I know I misspelled otherwise. I forgot the E, so I'm going to try to write it. There we go. Okay, so here we go. So we're in case 3. It says this. We will reject the null hypothesis if the standardized test statistic, STS, is greater than the plus critical value. Because when we do this in case 3, our critical value or values is plus or minus. Okay, we find this area, and then we get 2 of them, plus or minus. So here's what you do. You reject the null hypothesis if the STS is greater than the positive, or if the STS is less than the negative. So if either of those happen, that's when you reject the null hypothesis. If neither of those happen, you fail to reject it. Okay? So let's look at our problem now. Okay, this is what you do. Calculate the STS, decide what case you're in again, and see if the STS is less than the critical value, greater than whatever these descriptions say. Okay, so part 3, what does this problem say? So here's our standardized test statistic. I'm given the sample mean, population standard deviation, sample size. It's all given in the problem, right? It was all up there. Okay, so I use those numbers. Standardized test statistic, if I use a calculator, is about 6.59. Remember, my critical values were plus or minus 2.05. Now, what do we say? If either the STS is more than the positive plus critical value or less than the negative critical value. So in our case, so the STS is 6.59 and the positive critical value is 2.05. So 6.59, that's not less than the negative, okay, because this is a positive moment, but it is bigger than the positive. So look, yes, the STS is greater than or equal to the positive critical value. 6.59 is greater than or equal to 2.04. What do we do? In that case, we'll reject the null hypothesis. Okay? Now, what's the other side of the coin then? If I reject the null hypothesis, because here I see. So see, I can reject the null hypothesis, fail to reject, reject. So which one of these is what I'm doing? It's either A or D, because those are the ones that involve rejecting the null hypothesis, and that's what I'm doing. But what about this other stuff that comes after it? Well, let's talk about that. So I'm going to reject the null hypothesis. The other side of the coin is that means I'm going to support the alternate. It's either one or the other. Okay? From the beginning, when we talk about what the hypotheses are, if we reject one, we support the other. Okay? So in this case, if I'm rejecting the null hypothesis because that's what I'm supposed to do in this case, that's how the numbers work out, then I support the alternate. But the alternate hypothesis is also the claim that was made in the beginning. So in the beginning, somebody says the population mean is not 5,000. Okay? They're making that claim, and we're going to see if there's evidence to support that or not. Okay? So that makes the claim the alternate hypothesis. Okay, so here's what we do. We support the alternate, and because the alternate hypothesis is the claim that this question began with, we support the claim. Okay? Yeah, so we're rejecting that one because that's the way the numbers worked out. It means we're supporting this one. We're supporting the alternate, and we're supporting the claim. Okay, so look at how that answer would appear. Look at that last choice there. That last one, what's it say? This one right here. Reject the null hypothesis. Okay, at 4% significance, that's the alpha number, 0.044%. There is enough evidence to support the alternate hypothesis, or another way to say it is to support the claim.